Hello and welcome everyone to this session. My name is Nick Lewins and I lead financial services at Microsoft Research. Today's topic is data sharing ecosystems powered by privacy enhancing technologies. In just a moment we'll have a panel of industry experts in conversation on this topic, but first we're going to kick off with some visionary words from Bill Borden, who is Microsoft's Corporate Vice President for Financial Services. Over to you, Bill.
Thanks, Nick. Great to be here to talk to you about a vision for financial services. So post-pandemic, financial services institutions are moving full speed ahead to take advantage of a host of long-term benefits presented by digital transformation to be agile, build resilience, innovate, and grow. This has created an unprecedented demand for all kinds and forms of data and cloud technologies. Infrastructure as a service, platform as a service, software as a service solutions, with data analytics and machine learning at the core, are all top of mind. Data is on the move from thousands of on-prem data centers to a small number of hyperscale cloud providers, bringing huge opportunities to replace the industry's data copying batch processes for in-place sharing of live data in the cloud. Looking forward, we see where the industry is fundamentally transforming along three dimensions. First, all interactions are delivered digitally, and every aspect is extensively personalized based on a deep understanding of customer needs and in service of their financial well-being. That includes things like embedding human sales and service interaction via digital. So we see a renewed focus on personalization of digital experiences, integrating human collaboration into digital online sales and service. Of course, digital interactions create a data set that can drive better and better experiences in what we call a digital feedback loop. Second, data and AI. Data and AI will be applied in every decision process of the organization, implementing digital feedback loops that drive continuous optimization for customers, employees, products, and operations. Norms for responsible use of AI will have made it commonplace to use sophisticated AI in more heavily regulated use cases such as credit risk assessment and financial advice. Rapid advances in natural language processing will make it possible to parse and reason over complex concepts found in regulation, contracts, and legal interpretations. And thirdly, we see the embedding of financial services inside the experiences of other industries, such as retail, logistics, and supply chain. This means payments and similar financial processes are embedded in the digital experience that the customer is actually trying to achieve. This is because the financial processes are usually considered in the eyes of the customer friction that is necessary to achieve something else. So the endpoint of digital transformation of financial services is that this friction will be removed and the financial service will be entirely integrated in real time into the customer experience or business process that it is serving. So in summary, we're seeing a future that looks something like intelligent open banking on steroids, where humans incorporated into the experience are on demand. All of these trends speak strongly to the central role that data will play in the future of the industry. This includes customer data that you are the custodian of, data generated by your business, data sourced from your ecosystem, and open commercial and alternative data sets. I'm really excited about what the industry will build and what new technologies will be invented to allow data to be used for insight while protecting data rights and privacy of the data subjects and data owners. We are working closely with Microsoft Research and its industry research team to drive exploration of new technologies that can provide breakthroughs in all of the areas required to deliver this vision of the industry. It's a very exciting time for tech and a very exciting time for financial services.
As we heard from Bill, the digital economy of the future is built on data and interconnectivity. Last decade's major trend was the ubiquitous adoption of cloud-connected devices, and it could well be that the equivalent in the next decade will be the ubiquitous adoption of cloud-connected data sets. These data products will be shared within an ecosystem to create truly frictionless experiences, to create AI and ML insights that power new products, new experiences, and protect against societal harm such as money laundering and financial crime. In Microsoft Research, we're running a portfolio of initiatives to bring forward this vision, including strong cryptographic protection of sensitive data elements in cloud data estates, AI for quants, and responsible AI in the financial industry. And, of course, the topic of today's session, policy-based data sharing powered by privacy-enhancing technologies. This research is driven by the realization that data liquidity of the type we're talking about will only ever happen to the extent that it's possible to protect privacy, to use data within its approved purposes, to protect commercial interests and licensing of the data, to comply with bank secrecy laws, and with customer expectations on privacy. Making these assurances is not easy when the data is copied from one industry participant to the next, as is common in the pre-cloud industry architecture. As the industry moves to cloud, there's the opportunity for in-place sharing in the cloud and cloud-native data management practices to replace data copying between market participants. We're seeing these themes come up in multiple industry contexts and not just in financial services, and as a key part of numerous policy initiatives globally. For example, there's the open banking movement and its extension into embedded finance, the international data spaces and trusts projects for European data sovereignty, the future of financial data intelligence sharing in the UK, and the Singapore Banking Association's Trusted Data Sharing Framework. As this new data economy is formed, one of the key pieces will be technologies that can provide the required strong privacy guarantees. These are often called PETs, or privacy-enhancing technologies. They're a family of different technical methods that provide strong guarantees against information leakage. They're necessary to move beyond the procedural and contractual controls, for example, data use contracts, attestations, and access control lists, which are the current best practice for controlling data usage between organizations. Luckily, there are a number of such technologies that are emerging and are a focus of effort in the research community broadly and in Microsoft research specifically. These include trusted execution environments, which protect data by performing computation inside an isolated part of secure processes. Microsoft has a number of leading products in this space under the name of Azure Confidential Computing, and as an example, we've worked with the Royal Bank of Canada to create a virtual cleanroom solution for data sharing. Then there's differential privacy, in which enough statistical noise is added to query results in order to limit a querier's ability to infer specific data values. We have a strong collaboration with Harvard and open source solutions in this space. Then there's homomorphic encryption, which is computation on data whilst it's still encrypted. We have perhaps the most widely used open source SDK in that space. And finally, there are a number of cryptographic schemes such as secure multi-party computation and zero-knowledge proofs, which allow joint computation of results, or proofs, without sharing the underlying data, with a number of implementation SDKs available from Microsoft Research and others in this space. So to dive deeper into the use cases and the research status of PETs, let me introduce our panelists for today. Professor Florian Kerschbaum from the University of Waterloo Computer Science Department, who is an ACM Distinguished Scientist and Program Co-Chair for the PETS 2021 Symposium. And Dr. Cedric Membrez, PETS researcher from the Emerging Technologies Group at Swiss multinational bank UBS, who holds a PhD in mathematics from ETH in Switzerland. So now on to our panel questions. This first question is for Cedric. What use cases for PETs are most commonly discussed in the industry, and what would it mean for industries such as financial services if these methods can be deployed at scale?
Hi, Nick. Thanks a lot for the introduction. So there are currently many use cases using various techniques that are being discussed in the industry. And as you can imagine, data is one of the most important strategic assets in financial services. So it not only supports the competitiveness of existing business areas, but it also creates new opportunities as a part of insight-driven business models and value chains. So the challenge in financial services is that this data often includes sensitive and private information. So this means it has a high risk profile, and there are also many data privacy restrictions that apply. And so protecting this data and at the same time extracting value from it is a key objective in financial services. So when it comes to concrete use cases in the industry, I think we've seen several ideas that have been floating around for quite a while now. And these ideas employ techniques such as zero-knowledge proofs and differential privacy and secure multi-party computation, as well as many others. And when it comes to the potential use cases, I guess these use cases aren't only limited to the financial services industry, but are also applicable in other places as well. So I guess one common use case relates to the analysis of data that's distributed across data jurisdictions. So these data jurisdictions, they can be, well, real jurisdictions or kind of internal ones defined by regulations, so to speak. And in certain cases, the data cannot move across these boundaries imposed by these jurisdictions. And so the idea here is that using privacy-enhancing technologies, you can actually still do an analysis on this data, combine it in a private way across these jurisdictions, and gain insight from it. So let me think quickly. Sorry about that. So one idea is to use private set intersection and apply that to different business areas that have possibly a common set of clients. And so you can use private set intersection to figure out which clients are common to two different business areas. And based off this intersection, you can do something like a joint sales campaign. And so another idea of using private set intersection is to compute something like the overlap of customer bases of two companies that are planning on doing a merger, for example. And so we see that many potential use cases are based on the fact that regulations impose these restrictions on data movement. And in certain cases, you don't really need the data itself, but just some kind of aggregate statistic from the combined data set. So that's one common use case in the industry. I guess there are also many other use cases that rely on differential privacy and synthetic data. And so these techniques, they add noise to and also generate statistically similar data sets. And by doing this, you can actually process and analyze the data in a different data jurisdiction. So this means that you can develop quantitative models with synthetic data from other jurisdictions. Of course, you have questions regarding things like the utility versus the privacy of the data sets, but in general, these are valid use cases that are currently under investigation. And so zero-knowledge proofs have also been a big topic in the financial services industry. So for example, with zero-knowledge proofs, you can demonstrate that a certain number lies within a certain range. And you can do this without exposing the value. And so this allows you to prove that certain financial conditions are satisfied, which of course has implications for many other things. So for example, if you apply for a mortgage, you could prove that your salary is within a certain range, which would then be a statement of proof of your creditworthiness for a bank. And these zero-knowledge proofs, they can also be used in other cases within banks. For example, the Know Your Client process. That's a lengthy process within banks. And in this process, the banks have to verify that a potential client, they have to verify the identity of a potential client and actually show that this client has or satisfy certain attributes. And using zero-knowledge proofs, you can actually validate these attributes and keep the client's data private at the same time. So we have another really nice application there of zero-knowledge proofs. So when it comes to secure multi-party computation, there are also several ideas related to this that have been floating around. I guess here, one thing to note is that with secure multi-party computation, the data processing is split between multiple parties, but the inputs of the parties is kept private. And so this allows for data collaboration. And using secure multi-party computation, you could do interesting things like compute aggregate risk exposures of multiple financial institutions in order to get a system-wide view on the total risk exposure. Or you could do other things with secure multi-party computation, for example, secure trading. So that's also an interesting topic. Secure multi-party computation, it allows that it means that you can actually match buy and sell orders of financial instruments without any party ever seeing any prices or volumes. And so only the outcome of the transaction is then revealed to the parties. And I think that something similar has actually already been done in a practical example. So there's a famous example of a secure auction in Denmark. And you can try to take that same idea and extend it to other use cases. So as you can see, there are many ideas for privacy-enhancing technologies that are floating around. And I only mentioned a few techniques, but of course there are other ideas related to trusted execution environments and homomorphic encryption. And I guess it's up to the financial firms to, figure out how to employ these privacy-enhancing technologies to get the most benefit for their clients.
Thank you. Florian, would you like to add anything on use cases?
Cedric, I think you gave a very good overview. Thank you very much for that. I want to add a little bit of a systemization to it, as researchers like to do. And I think that we can see that privacy-enhancing technologies are applied alongside the entire data science lifecycle. So we see that things are employed at the phase of data acquisition, data collection, where most of the cases that Cedric now mentioned were being deployed. But there are also privacy-preserving and enhancing technologies are used later down the road when we actually train models to predict, or when we actually use machine learning models or other kind of data prediction models in order to do that. So we actually see privacy-enhancing technologies in the entire data science lifecycle.
Fantastic. So Florian, next question is for you. What are the hard research problems that need to be tackled across these spaces of pets, and which are the most active and exciting areas of research that you've seen to solve those hard problems?
Well, thank you, Nick, for this great question. So fundamentally, I think one of the big problems that we see in privacy-enhancing technology is that we really do not really know what privacy actually means. So we have been talking about, and Cedric has been talking about a lot about technical privacy, so data minimization. And that is certainly the concept that we need for technical privacy. On the other hand, we have legal aspects where in a lot of cases the question is, where is data being processed? And actually, Cedric talked about circumventing legal regulations with privacy technology. So this is another interesting aspect of whether or not these things could meet. And most importantly, what we are currently seeing is there's a very important user aspect in privacy. So for a very long time, privacy researchers have talked about the only way privacy-enhancing technologies are going to be adopted is by regulation. However, what we are currently seeing is that there actually is a lot of pull by the users to implement privacy-enhancing technologies in systems. And companies are trying to actively shape their privacy perception by employing such technologies. And this is a fundamental shift, because we now no longer as technologists have to implement certain regulations or try to circumvent certain regulations, but on the other hand, actually having to cater for a user's need. And we really don't know what that user's need means. So I can give a couple of examples. So we've been talking about differential privacy, right? So differential privacy protects an individual in a data set. However, what that specifically means, for example, if we apply machine learning models, whether or not the entire data set has an impact on the inference I want to make, or only the individual, is something we really don't always know, and we cannot really determine a priori. So we really don't know whether or not differential privacy is a technology that can protect us in that way. And it is not a technology where we know whether or not users understand it, or users can appreciate the consequences of differential privacy. So having a more holistic view and adjusting the privacy technologies to the needs and expectations of the user are really what we need to tackle in privacy-enhancing technologies in the future.
Yeah, it's certainly true that modern concepts of privacy go beyond just keeping information secret, which has kind of traditionally been the focus of cryptographic researchers and so on, and extend into concepts such as whether consent has been granted for the use of a particular piece of data for a particular purpose. And so I'm very keen to see the research community start to focus on strong controls for that element of privacy, as opposed to just cryptographic methods or methods that promise strong degrees of data secrecy. And so to flip that question around the other way, Florian, which of these technologies do you see as closest to broad adoption in practice, in your opinion, given, as you said, you need to consider the specific use case when you're contemplating which of these techniques in isolation or combination could solve for that particular use case?
So there are a couple of things to add to this. The first thing is we've always been told, and there was this folklore knowledge that privacy is not really something that is being picked up. However, we're currently seeing that most of these really advanced cryptographic and other techniques that Cedric has been talking about are now being used more and more. And what I believe that we will actually see being deployed is a combination of techniques. So to give you an example, we already have, and Microsoft actually is actively using differential privacy, local differential privacy in Microsoft Windows in order to collect data. So we have a use case of data collection again, and we have a technology that we can use. However, in order to still get the benefit of the data, the mathematical protection, the guarantee that differential privacy provides, needs to be actually circumvented, needs to be reduced to a almost unimportant quantity. However, if we now combine this with trusted execution environments, homomorphic encryption, or multi-party computation and other forms of encrypted computation, we can really actually leverage the benefit of differential privacy and the other technologies. So what I believe is that in terms of future deployments, what we're going to see is the different privacy technologies, including, as you mentioned, consent or user perception, playing off of each other and having technologies that complement each other and give a greater benefit than each individual technology of itself. And in such a way, us being able to get the best out of all of them, rather than taking an aspect. In order to even pin down further on that is that we have these encrypted computations, and we have consent, and we have output privacy by differential privacy, but actually only their combination is really capable and complements nicely to each other in order to provide us protection.
Fantastic. Florian, would you like to add anything on the hard research problems that you're seeing and which of these methods are closest to broad adoption in practice? Sorry, that was for Cedric.
Okay. Yeah, I mean, I basically agree with everything that Florian has said. But also from an industry perspective, I guess one of the research problems that we don't have enough knowledge of is pretty much related to the practical implementations of these technologies. And I'm not really talking about the security of the underlying protocols, but more about the security of the practical implementations of certain use cases. So I'm thinking about certain situations where users can in some way game the system, so to speak. For example, if you're a company and you have competitive knowledge and you want to let users access it, you might do this in the form of an encrypted model. But then that raises the question of model information leakage attacks, right? So I'm talking about model extraction and other possible security threats that might arise from this, from this deployment. And so I guess that's a big question that arises when we try to deploy these technologies. And of course, every financial firm is always interested in figuring out what can go wrong. And that's pretty much where the industry desires more information or more research.
Thank you again, Cedric. These were very good comments. I want to relate them back to what I said initially. If we're thinking about privacy in later stages of the data science lifecycle, as you mentioned, inference and protection of models, generation of models, we still have definitely several research challenges. But again, as I said in the other comment, is if we combine different privacy technologies, we might actually be able to tackle these challenges as well. Not that I agree that all of these challenges are solved, but I can give you some highlights, for example, on the ones that you mentioned. So we can use technology like, again, encrypted computation, all three forms that Nick mentioned at the beginning, in order to protect the inference. And if we want to protect against queries and leakage from the inference, we can use other techniques that allow us, for example, tracing of models, such as fingerprinting and or watermarking or other types of technologies that enable these types of things. So overall, we do have a range of technologies in the entire space of data science in the life cycle that we can hopefully employ in the future to protect also these use cases that you rightfully mentioned.
Yeah, it sounds very much from what you're saying, Florian, that there's not one silver bullet privacy enhancing technology where you can just tick the box and just say, just apply this one technology to my algorithm and it's going to solve all of these privacy protection problems. That it's much more a case of you need to understand the use case, and you maybe need to design a solution that comprises a number of these different privacy enhancing technologies to provide the specific privacy protections that your use case requires. Is that the way that you're thinking about it?
I fully agree, Nick. You also have to understand that people are still researching what data science is, and the data science process changes all the time, and we're inventing new data process technologies. And very often privacy is an afterthought that needs to adjust to these new developments, enhance them, and make them private and secure. And so this is indeed something where we need a lot of different types of technologies, as you said, in order to combine them.
That's a really interesting point. Just by combining all these different privacy-enhancing technologies, kind of like building blocks, you shouldn't forget that you're also increasing the complexity of the system, right? And that's when human failure might start to creep in. And so the challenge doesn't become easier, but it does enable many new applications, and it should be worth it. So.
Yes, perhaps it's a job of the future, the privacy enhancing technology engineer or architect or something, that we're going to need a lot of those people in the industry to deploy these technologies as we move forward. Well, I'm interested what has attracted each of you to spend your careers looking into this space. So Florian, would you like to go first and just tell us, give us some insight as to why you've chosen this space as a space to spend your career focusing on?
It's certainly a very interesting area, and I enjoy the aspects of these different things that play together here. It was a little bit of an accident for me as well, but as it is often is with a career. But one thing I particularly like is to have an algorithmic challenge. And in security or in privacy, we very often have an additional complication to the algorithmic challenge, which is to prevent something unwanted from happening. And to incorporate that into an algorithm that otherwise achieves the desired goal is a very, very interesting kind of challenge that always fascinated me.
And Cedric, what attracted you to work in this space?
I kind of see these techniques as a way to give control back to the user or client, right? So it's a way of counteracting potential misuse of private data. And even though these techniques, they're still in an early stage when it comes to deployment, they enable collaboration across various players, across various companies and industries. And my hope is that this new form of collaboration, or this enablement of collaboration, will lead to new applications that kind of make the economy much more efficient, and then everybody benefits. Yeah. Fantastic.
Another question for you both, to to start to close out the session, if people are interested in this space, and I'm thinking here both people in the research community and people on the more consumption side, people from financial services organizations and other industries, if they're interested in finding out more about this space, what conferences, resources would you highlight for people to start to get a better overview in this space and become involved in the community? Florian, do you want to kick off there?
Sure, happy to. So fundamentally, I believe this is a challenge generated by computers, and it has to be a challenge solved by computers or humans using those computers. So I very much believe in the fact that computer science will have to solve the privacy challenge that computer science generated. And as such, there are a lot of interesting kind of venues. One which you already mentioned, the PETS conference, which is the leading conference specialized on privacy-enhancing technologies. It's a very open community that welcomes practitioners and researchers. It is technically focused, but also in technology, it's open for a lot of different type of aspects of computer science, from human-computer interaction, of course, over cryptography, but also into machine learning and others. So there's really a confluence of technology that is coming together, and you can get a very good overview of what the current technical challenges are. And on the other hand, there are a lot of interesting organizations that have taken a lot of effort into collecting information on the subject. In Germany, there is, of course, always the famous Unabhängiges Landesdatenschutzzentrum Schleswig-Holstein, which Cedric for sure knows, which has collected a great source of information and has actually made an effort also to systemize it to some extent. And there are very many other sources and many other privacy commissioners which have done a very good job at providing an overview of the challenges and information that are out there.
Cedric, would you like to add to that?
Yes. So one thing to note is that the regulators, they've also kind of jumped on the topic. And for example, the Financial Conduct Authority, they've done hackathons based on privacy enhancing technologies. There are other organizations out there like the World Economic Forum, the EU, they all have working groups devoted to this topic. So you can find a wealth of information there with those organizations. And maybe on a personal note, what I like to do is I like to use the archive. So that's an online repository for scientific preprints. And just by looking at the latest publications there and reading the abstracts, you can find out a lot of information of what's going on in the field. And so I think that helps immensely.
Yeah, some of the resources that I point people to are the summary reports from the World Economic Forum on use of privacy-enhancing technologies in financial services, which is a very good summary, and the Royal Society report from the UK, which also provides a great overview of these technologies and their strengths and opportunities. And also I saw that the UK Information Commissioner's Office recently came out with a PETS adoption guide, which is a nice play on words. And that's a great resource as well for understanding these technologies and the ways that they can be deployed. Well, I'd like to start to close out here by thanking you both for spending the time with us today and for providing such a fascinating insight into the future of data sharing with these privacy-enhancing technologies. It's been a most enjoyable conversation, and I'm really excited to see how this technology changes the world in the years to come. Thanks again to both of you.